So what is crashing? So what we've looked at is we've been looking at the network and we've had a critical path. So remember, activities cannot be done unless, the activities before it are completed. So we've been doing that and we find out the critical path, which is, the earliest time that we could finish the whole project. So what's going to happen now is we've got that time, but companies will go, no, we want it done quicker. So what they're going to do is they call it crashing. So they might hire a few more employees and they'll crash one of the activities, meaning they'll do it and they'll pay more employees to get that activity done quicker and things. So because they want the overall project to be reduced in time. So there's a few ways that we can crash. So the first thing we're going to look at today is the crashing of we'll look at a single activity. So that's when we only affect one activity and we see what it has. Now, we'll see soon in our example, when you're crashing just one activity, or when you're crashing an activity, it needs to be on the critical path because the critical path is the one that makes affect the overall time. So if you crash one of the others, you might not affect the overall time. So we'll be looking at one of the activities on the critical path. So we'll then look at when we reduce multiple activities. So, they might say, no, we're going to have, more workers at 2 of the activities. And so we'll look at that. And what happens is that crashing comes with a cost. So yes, we might be able to reduce that activity. It may only take, 3 days instead of 5. But generally, you've had to hire some more employees or you'd have to do something. So then they come at a cost. So then sometimes maybe crashing a certain activity would be cheaper than crashing another because they'll give us costs. So we'll look at that finally. All right, so first of all, we're going to look at reducing a single activity. So if there's one critical path, so only if we've got one critical path, reducing any of the critical activities, that means any activity on that critical path will have a direct impact on the completion time. So if you change one of those activities on the critical path, it's going to change the completion time. Okay, so when you're going to do these crashing things, the best thing is to find the critical path. So we've looked at doing that by doing forward and backward tracking. So we're going to do that now. So forward and backward tracking. So I'm doing it in the colors that we have been doing it. So maybe we call it scanning. So let's have a practice of that here. So I'm going to start at the start. So I've got activity A and activity B. So they have a 0 waiting time. And then I move into C. C needs to wait for A to be finished. So that's 4. And if I look at D, D needs to wait for B to be finished. So that is 3. When I get up to this point, E needs to wait for C and D to be finished. So you've got to pick the bigger one. So if I came via C, it would be 9. If I came via D, it would be 10. So which one goes in there? 10. Good. And then we get to the finish, we add that 14, and so to be 24. So I'll just rub out those. Okay, so we've got to the end, and now we're going to do the backtracking, which I'll do in red. So I got 24, we minus the 14, that brings us back to 10. If I go backwards via the C way, it would be 10 minus 5, which would be 5. If I went backwards via the D way, it would be 10 minus 7, which is 3. Now just finishing off from down at the bottom. So the D, 3 minus 3, takes us back to 0, or up the top, I'm at C, which is 5, minus 4 is 1. So the critical path, remember, is the one where the numbers are matching, okay? So we would go along there. So if I find the critical path, it's going from activity B to activity D along there, okay? So that is our critical path. So if we're going to crash one activity, it's going to be one of those activities. So we'll write that down. So crashing activities on the critical path have the biggest impact. So we want to have, obviously, we want to have the biggest impact. So in this example, we're going to either crash B, D, or E. Okay? And what we're going to do, if they haven't give you, so often they give you restrictions as well. So sometimes they'll say you can crash B by 1 day. So that means you can reduce it. When we're going to do this, when you're not given any other restrictions, what you do is you crash the full amount. So we're going to crash completely. So we're going to go one at a time. So say, for example, if I crashed B, so I no longer had B there, what you would do, if you look, we would go from, we'd go along D, so it would be 7 here if we had no longer had B. And then if we went this way, we'd come along and we'd actually have 9, wouldn't we? So then we'd have to wait for that 9, and then we'd add 9, we'd have 14 to 9. So if we crash B, then the critical path ends up being 23. Okay, so really we only save 1 day if we crash B. Okay, now that's the same if I just crashed D. So if I took out D, it would be the same scenario, wouldn't it? Because we would then travel along the top, and that would become our critical path. So our critical path became 23 if we crashed D completely, and we would only save 1 day because it was originally 24, so now it's only 23. So if I crash E though, let's see what happens. So if I crashed E, I would no longer have that 14. It means once we got to the end of the diamond there, that would be the end. So if I crash D, my critical path it's only going to get, it'll be 10. So we actually save 14 days. So if I took that one out, so crashing E would have the biggest impact. So if they asked you what would be the best one, sorry, that's a bit small, biggest impact, what would the best single activity reduction? So if you got asked to crash one activity, and you've got no budget and you've got no limits, you would say I'll crash E, and that will save us the most time. All right, so we're looking at reducing a single activity. So if there are multiple critical paths, so here in this scenario, we're going to have, there's more than one critical path, and you've got to be aware that is a possibility. So only activities common to all critical paths will have a direct impact. So let's go find our critical path. So we're going to do a forward and backward tracking. So I've already put the squares in there. So if we have a look, so this is A, and this is B, and they are at the start, so they're a 0. If I follow along up to the top to C, so I've got 2 options after A. A leads into C and D. So they both have to wait for A to finish, so that's 3. If I look down the bottom, E has to wait for B to finish, so it's 6. When I get down to, say, this one down here, H has to wait for E, D, and F to be finished. So I need to make sure I get there first before I decide. So I'm going to go along up the top. So I've got, if I'm go along the C method, so you can see G is also there and F is over here. So if I go along C, which is a precursor for F, we need to do 3 plus 4. So these ones are 7. Now, if I came down this way, the 7 plus 5 would be 12. If I came along the E way to H, it'd be 6 plus 6, which is 12. If I came along the D way, it'd be 3 plus 7, which is 10. So which one am I going to put in? 12. Good. So that's why 12 gets put there. So I'll just rub out those other little numbers, but that's why they were there. I was checking. All right. Now I've got to go along H. So H is 12 plus 5. Now I'm going to put 17 because I've got to make sure it's bigger than the other way. So if I came along the G way, it'd be 14. So I'm putting 17 into there. Okay? So now I've got the end. I can backtrack. So 17, if I go via H, 17 minus 5 is 12. If I go along E, 12 minus 6 is 6, and then keep going back. 6 minus 6 is 0. So that's one way. Now I'm at H. What about if I go back via F? It'd be 12 minus 5. What's 12 minus 5? 7. Now what about if I was at the finish and I go backwards via G? It'd be 17 minus 7, which is 10. Okay, so that one's got a float. Now I'm up at, let's go backwards via C. So if I go backwards via C, 7 minus 4 is 3. So when you've got the two options up here, you have to pick your smallest. So we're picking the smallest there, yeah? So in red, you pick the smallest. So we've got 7. So 7 minus the 4 is 3. Now down here, it's 12. And if I go back via D, it'd be 12 minus 7, which is 5. So that one doesn't match. And then if I'm at A, so remember I've got to pick the smallest, which would be the 3. So 3 minus 3 is 0. So remember, it did say in this question, this one has two critical paths. So let's write them down. So two critical paths. Okay, so the first one I'll draw in green. If I go, I'm matching up the numbers, so 0, 0. C was 3, 3. F was the same, yeah? So we had the numbers were all the same. And then I went back to H. So that was one of them. So if I wrote that out, A, C, F, and H. And now if I look for the other one, so if I look here, so B was also 0, 0, and E, and you can see there, that was another way along the bottom, that also produced 17. So this critical path picked 17, and so does if you go B to E to H to the end, it's also 17. So that's two critical paths. So what we set up here, we said that if we're going to crash one activity, a single activity, and we're going to look at the one, it's only the one that's in common with both. So you can see, yeah, H and H is the one that won't. So all the rest won't affect. So maybe you write a little note. So individually, A, C, F, B, and E won't affect the critical path. And why that won't affect the critical path, won't affect the critical path if we crash one. Because if you just crash one of them, what happens is one of them is on one of the critical paths. So if you crash it, then the other critical path becomes the one and only critical path. So that's why it's no good. You've got to crash H. So here we would crash H because it's both of them, and it would save us 5 days, wouldn't it? So because we're going to take the 5 days off. All right, so that one is things. So, well, let's have a look if it would save 5 days. So let's have a look. So maybe also write a little note here that because H was common. Okay, so activity H will have the most impact as it will change the duration of the critical path. Now, so let's just do that. If I crash H, that means it would go down, that one would go down to 15. Okay, but if you have a look, if I crash H, so H is no longer there. If you look at it, we could then go the way via this way where we went A, we went C, so that would be 3 plus 4 is 7, plus the G, which is 7, which is 14. So can you see, if we crash H completely, the critical path would be 15. So really though, because 14 is the lower option, we only need to worry about so really we don't need to crash H by the full amount, because like of the 5 days, because even if we only crashed it by 3, it would still match the other thing. So let's just write that. Pardon?
14.
Yeah. So because 14 is the lower option, we can reduce 17. So remember, 17 is the original, by 3. So we only have to make sure that we don't go under the other option, which is 14. So if we reduce H, reduce 17 by 3, so that means 17 minus 3, that would equal 14. So you can see it would not affect, we'd still have the same critical path. It wouldn't affect it, because we don't want to change that. We'd still have to make sure G finishes. So it can either match G or that's it. All right, so because otherwise we're going to have to crash more. So H, if we minus 3 from H, that would bring that down to 14. So that's all we're going to do, because otherwise we'd have to pay for more. So, and not affect critical path. So, okay. What happens is we've got another way of finding that was sort of us inspecting it, the critical path. The table method, I think, is the way to go. It does take a bit more time, but you're going to make sure you see everything. And what you need to know, if you don't hesitate on what method you're going to do on the exam, you'll be fine. So this is where I would think the table method is your best option and probably the easiest. So let's have a look at this now. So crashing with the table method. The table method for the project crashing helps to keep track of all the possible reductions. So see that where we had that other option where G was, if you went the other way, it was 14. That's hard to see on the network. So if you do it in a table format, it's a lot easier to see. So this one, we're just going to be, we're just going to be doing a single reduction. Yeah. Okay, so that, so this table method, so we might write few little notes on this. So we're saying this method, this does show the critical path, but the only thing it doesn't show the float times, but, and not the individual things up that the other one does, but not individual. So that can make it hard to answer, you know, other leading questions. So whether they might say what's the start time or latest start time of an activity. But what you think, I think you should just do, have a look in reading time, see what you've got to do, and if you've got to get float times and earlier starting times, you're going to have to do your backtracking on your network. If you look down and you've got a crashing question, you're going to do the table as well. I think don't hesitate, just do it. It takes a bit of work, but you'll get it quicker. Okay, so let's go. So what you should do, the first thing is you identify all the possible paths from start to finish. So if you have a look, this is what we're doing. So if you look, AGI, that was like the first one. So we went along there, okay? So that was AGI, we wrote that path. And what you do, you got to write all the possibilities. So what I do is I start at the top and then we go, all right, this was another option. So you can see there, we did that one. And then we do the next one where we went along BFI. So you can see that was written down there. And then our last option we could do, you could go along the CDI, all right? So they're all the possible options to get from the start to the finish. So you write them down. And as you write them down, you write down how much the times are. So you can see if I went A, G, and H, that's 3 plus 6 plus 3 is 12. So we're writing all the possible times of the paths down. So when you do this, that's when you can see, now I know this one, the biggest number, that shows me the critical path. So when I said the table will show you the critical path, that's how you can work it out. And once you know the critical path, you should probably highlight it, so on your network, so you're aware of that. So we're aware of that. So it says apply. Now it's, once you've done that, apply each possible reduction. Now we've got to look at this example. For example, activities A, C, and F can be reduced by a maximum of 2 weeks. So here is extra restrictions on our crashing. Yeah, so this is what I'm talking about. No, so on our crashing. So we now can't just crash anything we like. We can only crash what they said. So they said you can crash A, C, and F by 2. So you can see here, I'm putting all the crash at what they can be crashed by. So A can be crashed by 2, C could be takeaway 2, and F could be takeaway 2. Now, I'm going to say I'm not going to worry about working out if I crash C. Why am I not worrying about that? Because C is not on the critical path. So maybe write a little note there. No need to check because it's not on. I'm just writing CP for critical path. Okay, so what I'm going to do is I'm going to do if I crash. Now, this is just a single activity. So in the question, it did say you're only going to do one reduction. Which one would be best? So if I look at crashing A, so I'm going to crash A. So every time the path, if you look down your paths, every time A is there, you would deduct 2. So this one will become 10. This one will become, what was that, 13. This one will become 13 because there's no A in there, and this one would remain 14. So when you do that, here is our new critical path. So reducing activity A by 2 will save 1 week, okay, because it went from 15 to 14, even though we took 2 away, okay? So that's what we would save. Now, we've got to check, see what F does. So F I'll do in blue. Okay, so I highlight everywhere I see F, and they're the ones I'm going to take 2 off. So the first one didn't have F, this one did, so it became 13. This one did, so it became 11, and this one's 14. So what's the new critical path? 14. So for that one, the new critical path, you'd only save 1 week because you went from 15. So we went from 15 to 14 on that option, and then this one went from 15 to 14. So we'd only save 1 week. So if in the answer to this question, if you are answering this answer, you would say A or F, the best single reduction, because you only were doing 1. The best single reduction saving 1 week. Okay? Okay, so with this one example, we're going to keep practicing this table method. So for the example, it says what single reduction, so we're only going to cut or crash 1 activity, should be applied to achieve the best overall completion time. So what we need to do is we need to find all the possible paths that we can get from start to finish. So say for the first one, I could go B, G, I and J. So into that first part of the table, I'm going to write B, G, I and J. And then what I'll do is I'll just rub that one out. I'm just highlighting to help you. So then I could find my next possible way through the system. So I could go B, use this dummy, F and J. So there's another one, B, F and J. Then I could go again, still using that dummy, B down the dummy, but this time I'll go through the C, E, H and J. So I'm just working all my options from top to bottom because I find this way, hopefully I don't miss any. Okay, so I think there's no more options using B. So I will now, so I'm just rubbing that out. So I will now go and use A and give it a go. So A, I could go A straight across. So there's one option. So A, F and J. And then my other option could be this A, C, E, H and J. So I pop that one in, A, C, E, H and J. And I probably should have, while I was doing those paths, I probably should have added up how long they take. So if I look at, just to show you how I've done it, the first one, this B, G, I, J, we would have added 5, 3, 8 and 1, and that would have been added up to 17. Okay, so then if I go through and I'll add up all the rest. Oops, sorry, deleted that one by accident. Sorry, B, G, I and J. So if I go through and count up all the rest, these were the times for the other ones. So once you've got the original path times, we can see the critical path. So 19 is the biggest, so that's our critical path. So once you find your critical path, you should really go and highlight it on your network. So I'm going to go highlight, and we went to B, we used the dummy, we went down to C, E, H and J. Now we know that we'll get the best impact by crashing one of the critical paths, and so therefore I'm going to crash one of those. Now there's no other restrictions here. They didn't say that I can only restrict it by so many. So what I'm going to do is crash them the full. So if one option is I'll crash B, and I can take away 5, the maximum, because that's what B is,
And then if I look at C, C is 2, so I can crash, if I try to crash C, it'll be take away 2. If I crash E, it'll be take away 7. If I crash H, it'll be take away 4. And if I crash say J, I'll take away 1. And I'll just put that one in, that one in yellow so you can sort of see. Alright, so we're going to go through and crash all them. So maybe we'll just write a note of what we did there in terms of, we said, because we were told no other restrictions, we will try crashing each of them by the full amount. Okay, so the first one I'm going to do is the B. I'm going to try if I crash B. So what you do is you highlight in all your paths where B occurred. And in that one, you're going to minus 5 from all of those path times. So this first one, 17 minus 5, it becomes 12. And 18 minus 5 becomes 13. And 19 minus 5 becomes 14. Now these last two didn't have B in it, so they remain the same. So this is my new situation, and if you see now, the critical path for the new situation now will be take 15. So if you think about what have we gone to go from 9, it was 19 to go to 15, it means we've saved 4 days by crashing activity B. Now we crashed it by 5, but if you look, if I only crashed, if I crash this one by only 4, I would get 15. So that would still be the critical path. So that means that one's okay to only, so you see what you'd need to do to get down to your new critical path time. So I would only have to minus 4 there to get this one to 15, and then all the rest. And so here, and if you look at that, all the rest are smaller anyway. So what I could do, or this one actually, what I'd have to do, I'd minus it by 2 to get to 15. So we can see here, to make this one, we really only have to reduce B by 4. So to get 19 days, the old original, down to 15, because it has to match the new critical path, we would only need to have to reduce B by 4. So why we're going to do that is because we're going to soon see that these things come at a cost. So better if reducing it by 5 would make the same result as reducing it by 4. Well, I'm going to do 4 because and save money on, say, extra workers or something. All right, so the next one we're going to do, so we've done that one. So now I'm going to do if I crashed C. So if I crash C, I look for C in my paths, and every time I see a C, I'll take away 2. So 2 from the original. So this one didn't have any C, so they remain the same. This one, had a C, so it goes to 17. This one didn't have a C, and this one becomes 13. So you can see the new critical path is 18. Oops. So you can see it. So to get from the original 19 to 18, we need to, we're saving 1 day, really. Okay, so we're only going to save 1 day. So really, to get this 19 down to 18, we'd only have to minus 1. So we could really, the way we're going to solve that is just by minusing 1 C. That would be the saving of that. All right, let's go check E. So E, I'm going to if I crashed E. So I'll look down and I'm going to see every time I see E, I'll highlight blue. Okay, and then I'll deduct those ones. So I've got, no change to those two. This one I'm going to deduct 7, so it became 12. No change to that one, and this one became 8. So once again, we see 18 is our new critical path. So we'd only have to minus, if we want to get them all down to 18. So if you look at the originals here, so to get 19 down to 18, this one here, we'd only have to minus 1 E, okay? And then if you look at the one down here with the other E, 15, it's already smaller. So really, the only one if we were picking E, we would only save 1 day, and we'd only have to take 1 E away, and we'd get the same result. Okay, then let's look at H. So every time we see a H, I'm doing it in pink, we're going to see, we'll deduct 4. So no change to these ones. We'll deduct 4 off this one, becomes 15, 14, and 11. So once again, the new critical path is 18. So to go from the original 19 to 18, we're really only saving 1 day. And if you look at, and we'd only have to reduce it by 1. So H, we'd only have to crash H by 1 to get to the new thing. So we'd only have to crash 1, and we'd only save 1 day. All right, so then the last one, where J, we're going to minus 1. So I just did it in yellow. So the J is in all of them. So we're going to see them all reduce by 1. And then once again, so just so you know, so that was, sorry. So they were all the yellow ones. I'll just do it like that. Once again, we see the new critical path is 18. So we only need to get our things down. This one, the 19, is the only one bigger, and then we'd only save 1 day, and we'd only have to deduct J by 1 to save that. Okay, so we probably could write we can write a little comment there that these guys, they only saved 1 day, only 1 day saved, because it went from 19 to 18, so only 1 day. So the best impact for this one, so the answer for this is what single reduction? So write the answer. The best single reduction will be activity B, and which will save 4 days. Okay, so it'll save 4 days, and best single reduction will be to save 4 days. So new completion time is 15 days, and we only needed to crash B by 4. Even though we could do 5, we don't need to. We just need to do 4.
Okay, so here's altering a single activity. So, for example, the network below shows activities that are needed to finish a particular project and their completion time in days. The project currently has 1 critical path. A second critical path, in addition to the first, would be created by... Now, this is where we're getting... so it only has one critical path at the moment, but if we make these changes or crashes down here, it's saying what will happen. So what we need to do is we are going to do all our options. So you can see we've put in all the options from start to finish. And then what we're going to do is we're going to test out their days. So I've put all the original times. So what would the critical path be in the original time? It'd be, what's the length of it? 22. Good. So we've got 22 would be the length of it. So what we're going to do, they said one option is to add 7 to D. So what I'm gonna do this in purple. So I look down and I find anyone that has D in it, and it's just the first one, and I'll add 7 to that. So 7 to that is 22, and the rest remain the same. So look, when I did that, what happened is, what's the critical path? It's 22, but there's 2 of them. So this is a multi-choice, so it's looking like that gave me exactly what they wanted. But let's just double check, and we'll use the other ones. So what if I did the G plus 1? So everywhere I saw G, I'm going to add a day. So it was just at that end one. So I would go 15, 13, 12, 22, 21, and we add 1 to this one. So this one, the critical path is still just 1, and it's still 22, so that didn't work. If I do I add 2, so just go through your paths and find where I is. All right, so we're giving the C, we're checking the C option, so where we added 2, so we found for I, so we found I in our paths, and then we added 2. Now, because 23, it would be the new critical path, so that would actually take longer, but the question wants us to find the situation which would create 2, which we've already found, so we don't want to use either. So, but we're just going to keep checking our answers. So let's check the next one. Now, this is where we reduce C by 1. So every time we see C in our path, I'm going to take away 1. So I'd have, this one didn't change, this one didn't change, this one we're going to reduce this one by 1, which would be 21, and this would be 20, and this would be 19. So the new critical path would be 21, but there's only 1 of them. And then if we do the last one, say H, we're going to take away 2. So every time we see H in our path, we're going to take away 2. So this one didn't change. This one did change to 11. This one stayed the same. Take away 2, this one became 20, this one stayed 21 and 20. So the new critical path would be 21, but there's only 1. So we've backed up our answer. We know that one is correct.